If I want to find the derivative of sine inverse x, let me first write y equals sine inverse x. And then I want to find dy over dx. Here is something you want to notice. Y belongs to the range of sine inverse is in the first and the fourth quadrants. So you plug between -1 and 1 and your answer lies in this range. Okay, so with that, let's go ahead and try to find dy over dx. If I just take the derivative on both sides, I'm not going to get anything because I don't know what the derivative of sine inverse x is. So let me rewrite this equation as sine y equals x. I'm applying sine function on both sides. Now I can use implicit differentiation. So I differentiate both sides. The derivative of sine y is, remember, we are using implicit differentiation. We are differentiating with respect to x. So derivative of sine y is not just cosine y, but you would have to multiply with dy over dx. And that is equal to the derivative of x is just 1. Which means to get dy over dx, I need to divide both sides by cosine y. So cosine y, how do I get this in terms of x? I know x is sine y, but I want cosine y. So here is the Pythagorean identity that I'm going to use. Sine square y plus cosine square y is equal to 1, which means cosine square y is 1 minus sine square y, and cosine y would then be square root of 1 minus sine square y. And here is where I know that the answer would have to be positive, because if y is in the first and fourth quadrants, there cosine y is always going to be positive. So there is no doubt whether it's positive or negative. It's always going to be positive because y is either a fourth quadrant or a first quadrant angle, and cosine is positive in both of those quadrants. So this is going to be, now sine y is x, so I'm going to have square root of 1 minus x square. So that's my derivative. What is dy over dx? Is 1 over square root of 1 minus x square. So that's the derivative of sine inverse x. Now let's go ahead and do a similar process to figure out the derivative of cosine inverse x. So I'm going to write y equals cosine inverse x, and notice that y, the range of cosine is in the first and second quadrants. So anytime you take cosine inverse, you either get an angle in the first quadrant or the second quadrant. And oops, not sine y, this time it's cosine y equals x. You differentiate, you get negative sine y dy over dx is equal to 1. Dy over dx is, and I can move that negative 1 over sine y. And again, sine y is square root of 1 minus cos square y. And again, this is positive because your y is either in the first or second quadrant, and sine is positive in both of those quadrants. So this is going to be square root of 1 minus x square because cosine y is x. So what is the derivative of cosine inverse x? It happens to be negative 1 over square root of 1 minus x square. Now sine inverse and cosine inverse derivatives only differ by this negative sign. So this was the derivative of sine inverse x. It was positive 1 over square root 1 minus x square, and cosine inverse is negative. And this should make sense because there is an identity in trigonometry that you can prove. Sine inverse x plus cos inverse x is just a constant. It's positive pi over 2. So if you were to differentiate, then this goes to 0, which means the derivative of sine inverse and cosine inverse are opposites. And that's what we just saw.